Rotation is the name of this lesson, and it's going to be referring to the typical ways that people manipulate rotations of game objects within Unity. Most people use what are so-called Euler angles, which is a way to rotate an object anywhere in space using three axes. There are several problems with this approach, and there are serious advantages. To get the best of both worlds, Unity uses something called quaternions underneath the hood. Let's pop into Blender and get a hands-on explanation, and then write a simple script that utilizes these concepts. When CG animators make animation, they utilize a rotation system called Euler angles. Euler angles can take any object and rotate it at any angle specified by three axes. Each one can be manipulated individually, but not independently. Because of this, and because of the ease of use of Euler curves, a huge advantage of them is visual simplicity, allowing animators to make animation curves with ease. Unity uses Euler angles only as a visual cue. Like I said, under the hood, it's quaternions. There are a couple of reasons for this. To see why, let's look at a second model, which has all of the three axes visually represented. Whenever an object is rotated, it is rotated in order. Sometimes, for example, an X can be first, Y can be second, and Z can be third, but these can be in any order. It can go Z as first, Y second, and X as in third, but they go sequentially. The code itself, it will rotate one axis after another. But even if you're not doing this without code, this system itself is called a gimbal, and it requires a hierarchical structure. The system that I have is that I have X as this represented by this torus, which is at the top of the hierarchy. Its immediate child is the Y-axis, which is green, and its grandchild is the Z-axis. Using this system, I can position the arrow wherever I like. Because of its hierarchical approach, however, we will soon run into a problem. Both of these axes are now in the same position. This is something that's called a gimbal lock. If I then try to rotate the object on the x-axis, I won't be able to, because it is on the same axis as the z. Your 3D program will try to resolve this, but it will look pretty weird. There are other problems with Euler, but the gimbal lock is alone pretty huge. Instead of Euler curves, Unity uses something that's called quaternions. Quaternions don't suffer from gimbal lock, and instead of X, Y, and Z angles, they use something that's called tension, continuity, and bias. In Unity, it positions it on a unit quaternion. You can think of it as this sphere with a point on its surface with a vector constantly pointing at the center. Quaternions are also much better suited at handling something called slurp, or spherical interpolation, which is a way to transition from one point to another on a curve. Technically, quaternions are four-dimensional imaginary numbers, and they involve some crazy maths, not something that can really be learned in one evening. Just think of them as a black box. We don't really care what happens inside. We give it a value, and we want to get something in return, and Unity will solve it for us with quaternions. So let's see it in action. Okay guys, so what I want to do to get started is to create some sort of indicator that will turn on a target. And for this we'll use quaternions and the slurp, the interpolation algorithm. So to get started, just drag in the arrow model that's in the models folder. zero out the transform. And let's make it a little bigger just to get a more of a visual cue. That's good enough. Now I want this arrow to point at an object wherever I move it. So let's just create a regular cube. Perfect. The bulk of the explanation is going to be in the code, so let's make a new C# script. I'm going to call this rotation indicator. I'll just double click to open it up in MonoDevelop. Okay, well, it comes with this template. I'm going to delete both of these. I'm going to create this from scratch. Okay, so first, before we get into it, let's just set up a couple of public references. I'm going to reference what this object is going to be actually pointing towards. So let's set up a public transform reference. And let's give it a nice boring name, target. Cool. Okay, well, here's what I have in mind. We take the cube, and every time the user presses a command, the cube will move to a random position. This way, every time we want to move it to a different position to have the arrow indicate where it is, we don't have to move it around manually in the inspector, not inspector, the editor. I want the arrow to constantly indicate where the cube is, unless I say otherwise. So the way that I'm thinking of doing this is to create two states, one for activating the rotation and a second state so the arrow won't follow around the cube and will just zero out all of its rotation, or use the identity state of the quaternion, meaning everything will just get zeroed out. Okay, well, let's get some letters on the screen before I forget everything. We're going to create a boolean here. I'm just going to call it toggler. And I also want to create a position, so that's going to be a point somewhere on in space that's going to be the random position, and I want this to be accessible throughout the entire class, so I'm going to assign it here. It's going to be a vector 3, and I'm just going to call it random position. We don't need to initialize any of these variables. All of them will be accessed per frame. So I'm going to create an update function. And the way that we're going to get this random position and the way that we're going to switch on and switch off the rotation algorithm, it will be just by pressing keys. So if we press keys, what do we need? We need the input class. So boolean space equals input class, and we want to get the get key down boolean, and it's going to be key code that space. And this function, every time the user presses down the button for one frame, it will toggle the space boolean on. Okay, and let's create a second one. This one I'm just going to press the R key for random. Same thing, get key down, key code, .r. Okay, we're not doing anything with quaternions yet. At this point, I'd just like to say, hey, if the user presses R, then move the cube to a random position within my range. So we need to create a conditional statement asking if this boolean is true. So if the key code R has been met, if this is true, then I continue on with this conditional, and it's simply going to give a random position to the cube. So we need to access our variable, and we're going to need to give it a new vector 3 coordinate. And to do so, we're going to use the random class and the range function. And within this, we just want to give it some sort of space and several of the axes to position it randomly throughout some sort of range. I'm just going to put -10 and 10. Then I need to assign this for the y. Same thing, it's fine, and for the z. Let's close out these parentheses. That's all we need to do. Okay, before I set up the conditional to toggle the indication state on and off, let's just have it follow just to see if it works. So I'm going to write transform that rotation, and this is going to be a quaternion, as you can see here. So we're going to need to access the quaternion class and use the look rotation function. There's also a very similar function to this. It is going to be within the transform class and it's going to be called look at, but this will satisfy the task. And that's it. We are specifying a vector 3 that is the position of the target, which is going to be the cube. Okay, Unity is going to give us a couple alerts that we're not utilizing the space boolean, but besides that, I don't think we should get a clean console. Excellent. Just take the script and drop it off on the arrow. And within the arrow, we're going to have a public reference of the target. Drop off, not the main camera, the cube. And speaking of actually the camera, I don't have the random position assigned, but this seems to be working. And so check this out. Even though if we look at the arrow, we will see its rotation listed as Euler angles, what it's really doing behind the scenes is taking this vector and positioning it on a different point using several aspects of a quaternion, not an Euler system. This is there for visual comprehension for human beings. Excellent. Let's get back to the code. Okay, so now we want this to happen within a state, right? So then we want to ask if the state is true or false, and then we can specify upon which conditions the state will be true or false. So we'd say only do this if the state is not on, right? So I want to say if not toggler, this would be the same thing as if toggler false. It's just a shorthand. And how will we let Unity know when toggler is true or false? Well, when we press space. So if space, right, if this boolean is met, we want to first of all toggle the toggler. So what are we going to do? We're going to write toggler equals not toggler. And what this will do is set the value to the opposite of what it is now. So it's saying if this is true, and it's saying set what's currently true to not true. So not true being false, and if set false to not false, so it will become true. And after that's been set off, I want to reset my arrow. And to do so, we're going to use the identity state of the rotation of the quaternion. So transform that rotation equals quaternion dot identity. And we're going to use the slurp function to give interpolation from one point to another for the target, for which we currently have assigned the cube. So target dot position equals vector 3. We're going to use an inherited method here, slurp. By the way, there's a slurp and then there's also a lerp. A slurp is a spherical interpolation and a lerp is linear interpolation. Linear is a continuous line, a continuous movement from one point to another, and spherical does this on a curve, quarter segment of a circle to be precise. So it's slow in the beginning and then it speeds up. Let's use slurp. Slurp, and for the slurp function we want to tell it, we'll start from this and end at that, and how long will it take us to get there. And in that sense it gives us a 0 to 1 value, and depending on where it is, either from 0 to 1, it will then transfer it to that point. So if we put in target, target that position, the position of the cube, and we want to give it the value of random position, which we just assigned here. And the time that we want to give it, I'm just going to put time.delta time to make it frame rate independent. So let's just review our code really quick. We're giving two booleans here that are drawing two key codes up here. If the R key is pressed, we're getting a random range. If toggler state is false, and it is false by default, then have the arrow constantly look at the target, or the current point in space where the target is located. And then if the space key is pressed, then toggle the toggler and then reset the rotation of the arrow. So if we press space twice, it will get us back to a state where the arrow will rotate again. And then have the position of the target go into a random point every time we press space with a slurp interpolation. Or I guess that's somewhat tautological with a slurp function then, or a spherical interpolation. And we see that the cube goes immediately to 0. It's because the vector is initialized as 0, 0, 0. But if I press R, I should get a random value. Okay, and there it is. And we see the arrow is pointing directly to the cube. Well, I hope this resolves some of your confusion. I know I was very confused when I was using quaternions to program, but it appeared that Unity gave me the settings in Euler angles. And lastly, I just really like to recommend the page on the quaternion class within the scripting reference. Unity has a pretty large library that has to do with rotations. It will make scripting easy and fun, so you don't have to fry out your synapses with four-dimensional imaginary numbers and the like.